This is Aishwarya from EC department. I am currently working as an assistant professor at SNS College of Engineering. So today's topic is monostable multivibrate. Okay. So a mono means it has two states, that is one stable state and one crashing state, that is stable and unstable state. Okay. So this is the functional diagram of monostable multivibrator. So in this multivibrator we have two comparators, that is comparator 1, comparator 2, one flip-flop diagram here. So the function of this monostable multivibrator is, initially we assume a Q equal to 1 and Q0 equal to 0. Initially just we assume. So that the value is here, the value is 0. Okay. So this value 0 means Q is 1. This 1 signal is given to this transistor so that the transistor will enable. And that signal is given to this pin, 7th pin, discharge pin, so that the capacitor will start discharge the value here. Capacitor will start the discharging process here, that is discharging process here. Okay. So in this time this signal is connected here, so it is given to the non-inverting terminal of comparator 1. Okay. So the VCC signal is splitted here is 2 by 3 VCC and 1 by 3 VCC here. So it will compare the value 2 by 3 VCC here. So it will compare the value of 2 by 3 VCC and this negative voltage signal. So the value is high in inverting terminal, so that the comparator will goes to low stage. Okay. So what about comparator 2 means there is no connection between here, because the 6th pin is the capacitor discharging value is connected only to the comparator value, so that the Q will, now the Q is equal to 0, so the value of Q equal to 0. Okay. So what about comparator 2 means, here the trigger pin, trigger input is here. When we apply the trigger input to this comparator 2, that time only it will produce the high output here. Okay. So now I will apply the trigger input to the comparator 2. So this time the value is now high. That signal is given to the flip-flop, so that R equal to 1 and Q bar equal to 1. So second condition, I apply the trigger input here, so that the output voltage goes to the high stage. Okay. So that the output is goes to the high stage. So the capacitor will charge the value. Why means, so now the R equal to 1 means the Q value is 0 here, right? So this value is given to this transistor and this transistor goes to the off condition. So there is no connection between a 7th pin and this transistor. Okay. So that there is no connection means the capacitor will take the input signal from this positive VCC. So this VCC is given to this capacitor C. So the capacitor will charge the value. In this time the capacitor will start the charging process, so that the capacitor will goes to charge the value. Again a value, like again if charge means the value is given to the comparator, so the value is very high here, so that comparator again produce the high output here. The comparator will produce the high output here. Here the value is high means the reset goes to 0, the reset goes to the low value here. Okay. Again I apply trigger input means the R value is goes to 1 and the capacitor will charge the value. Okay. So this is the concept of monostable multivibrator. Okay. So let us discuss the equation of monostable multivibrator. So this is a derivation, that is a pulse width derivation. We know that formula, I think we discussed in unstable multivibrator also. So Vc equal to V into 1 minus e power minus t by R into C. Here a Vc is 2 by 3 Vcc, because in 2 by 3 Vcc we will the comparator T on only. R here we used only one resistor here, that is RA, so that value is written here, R equal to RA. So these values are put in this equation. So 2 by 3 VCC equal to VCC into 1 minus e power T represented as T on by RA into C. Okay. So in this condition the VCC will be cancelled. So it write as 2 by 3 equal to 1 minus e power minus T on by RA into C. Okay. So in this condition this one is written here. So taken LCM means the value is written as minus 1 by 3 equal to minus e power T on by RA into C. Okay. After cancellation of this value, the value is written T on and RAC is here, and the value is given to here. The e power 1 by 3 value is minus 1.09. Okay. So this value now the minus and minus will be cancelled. So we know that we need only T on value. So T on equal to this value is written here. So 1.1 into RA into C. Okay. The pulse width value. The pulse width is written as W equal to 1.1 into RA into C. Okay. The applications of this monostable multivibrator is frequency divider, PWM and timer, like that. So this is the basic concept and working process of this multivibrator. Thank you.